I'll just say, if you can't hear me at the back, tell me, and I'll use a microphone. Otherwise, I'm going to endeavour to project my voice to the back of the room. But in case I don't have that kind of ability, or halfway through I start to flag, just wave your hand at me and tell me that you can't hear what I'm saying. So my name's Paul. I'm the training manager at i2 Software, which means that I'm responsible for the tutorials and things like this, and anything else really that falls under my remit to do with training. Sometimes I liaise with other third-party people that are doing training, sometimes other educators. I'm joined today by my colleague Daniel, who's at the back there. Daniel is the CEO of i2 Soft, one of the original founders, along with his brother Carlos. We'll learn a little bit more about how they got started in a minute, because that's a story we haven't actually told before. And yes, as I say, today I'm going to talk about creating large-scale environments with Forest Pack and RailClone. Who here is already a Forest Pack user? Wow, okay. And who's a RailClone user? Still not bad, good. Okay, so we're covering both plugins, and we're going to do this via a series of projects, which I'll show you in a minute. Sadly, not this one by the Boundary, which is a really nice project you've probably seen on social media lately. But this has got extensive Forest Pack use and would have needed quite a lot of optimization to create large-scale environments like this. But we'll look at some of those techniques. We are going to start with some grounding, but we're going to jump around a little bit. So I'm going to go through these projects, talk about some fundamentals, and then springboard off of that in a series of diversions that go a little bit deeper into certain tips and techniques, and also look at some of the newer features of both plugins. So that's who we are, as you know. So, a few things about the names. We called this Forest Pack a long time ago. That's been great because it's a snappy name, people understand what it means. Good for trees, right? That's also been a little bit of a hindrance because sometimes people think Forest Pack's for trees. And Forest Pack isn't just for trees, as most of you are aware. Forest Pack is useful for scattering anything, especially anything that's got a high polygon count. But I have had conversations with people in the past where they've said, yeah, I use Forest Pack for my trees, and I use, and I'm not going to mention the other scatterers, to scatter the rocks and everything else. Why? Why don't you use Forest Pack for both? So, just to go over that, Forest Pack is a general purpose scattering tool. Yes, it's got forest in the name, but it's all sorts. And RailClone, the name's fairly descriptive there too. It clones things along rails. Okay, those names are fairly understandable. And we'll go more into the complexities of that in a little bit too. i2, on the other hand, is a less obvious name. And this is why I just want to talk a little bit about where we came from. So i2 as a name, people ask where did that come from, what does that mean? And in order to learn that you have to go back a few years to 1995, which is when i2, the name, and the kind of company, if you want to call it that at the time, first started. So I don't know how many of you remember, or how many of you were born even, in the 80s and 90s, there was a kind of a demo scene that grew up around software at the time. And basically what it was a group of very clever programmers who were trying to do things with their hardware and software that were pushing the boundaries of what was possible. So as an example, I remember I had an Atari ST. Who had an Atari ST? Anyone else? Way back? Wow, very few people. Make me feel old. I had an Atari ST at the time, and one of the limitations of the Atari ST was that the screen had a border around it. Don't know, right? So you never got to fill the full screen like this. It always had a hard border around it. And in the demo scene, what was happening was that people were trying to break that hardware restriction and fill that border in with software, make it full screen basically. At the time, we'd all be excitedly sharing 3.5-inch floppy disks around, you know, like a 600th generation copy of this thing, going, check out this demo, they filled in the left border. Look at it, it's got a line in it that goes up and down, really exciting. Then you get another one a few years later, going, oh, they've done the right border, can you believe it? And eventually they did all the borders, and you got like full screen Atari ST. And when I was looking this up for this presentation, what I found fascinating was that they're still doing it. There are still people that are trying to find the best way to fill in the borders on this old computer. So like the most recent one was, you know, a couple of years ago, and they'd finally got, you know, the ultimate version. So this is kind of where i2 started in the demo scene. A little bit later in the 90s, and there was a demo group called Hispania, and this is a particular demo that guys, Daniel back there and Carlos, who isn't here, got involved with. So this was what a typical demo looked like. It would be a kind of compendium of achievements put together by this group. This is sick, by the way, just to get sense of humour time. This guy has. So what Carlos and Daniel were responsible for was the very last part of this demo, which was a 3D engine that was written entirely in assembly. This is what assembly looks like when you code it. It's not particularly user-friendly. So they took, I think it was about 3 months of intensive work and wrote this entire 3D engine in assembly. Now bear in mind this is 95 and the hardware is primitive. But I'm really pleased that I've actually we've been able to track down the original demo on YouTube. And this was the kind of written in assembly in 1995 on an old computer. 3D demo. There is some really cool music with this, by the way, if you can hear it. So it's getting solid, it's moving around. And it's transparent, we're going to get some fire in a minute. Commodore logo. There we go, look at this. So, I mean, written in assembly, this was a real achievement at the time. You know, this is something that would have been difficult to do. But also, what's significant about this particular demo is it's the first public reveal of i2. Because in this demo, there was a credits scene where each of the individual contributors were listed. And here we have Daniel, he's at the back. You can see it's the i2 brothers. So this is where i2 comes from. This demo, i2 brothers. And the i2 in this case means they were the last people to join this group. And in this case, they were like, me too, I would like to join. I want to join this hacker group. And that's where the kind of name came from. So this is Daniel. And here we have Carlos, who I'm told he's in the computer because he was so busy coding, he never left the kind of office. So this is the very origins of i2. To actually get into Forest Pack, you have to go back to the future. You have to go back to 1998. And this is when Forest Pack was born, when Daniel at the time was then a 3D artist, a visualizer, who was tasked with creating a golf course in 98, remember? And of course this golf course had a lot of trees. I should point out this is a photo of the golf course as it is now, not a visualization from 1998. Now at the time there was no real scattering plugins, certainly not 3ds Max. And so Daniel faced either the troubling prospect of placing hundreds of trees by hand. Trees were billboards at this point as well, I should point out. Or he had to fall back on his coding skills and decided that it was more sensible to develop some kind of software to make this easier for him. And that's where Forest Pack comes from. And in fact, I could find not actually the year of its release, but the year after, there was, on the Wayback Machine, there is the original i2 software website from 1999. Look how cool that looks. So this is what we looked like in 1999. And then here's our product page, and it goes through a lot of features. I mean, it's interesting because some of the kind of core of what Forest Pack does is still here. But what I really like is this claim here that it can create more than 50,000 trees per second on a Pentium 2 350. Now, that is an underpowered processor by today's standards. But I think what's interesting is this claim because it's all about this ability to wring the most performance out of your hardware and your software, and that is still what i2Soft is about. And so what we want to do today is to look at 3 projects, or there are 4 projects there. We may not get through them all depending on how much I talk. But we're going to focus on a couple in particular, which is the Niskota one and the Bertrand Benoit one. And we want to look at the ways in which Forest Pack and RailClone can be used to push the limits of what's possible in terms of polygon counts, but also offer you as artists a lot of control over how you distribute all that geometry. So both the Studio Niskota and the Bertrand Benoit scene were personal projects. The 2 visual effects projects were obviously proper commissions. LUXX Studios Independence Day, Screenscene VFX is Black Sails. We're going to start with Studio Niskota. Has anyone seen this image before? Okay. So this was an image that we saw Studio Niskota who did a talk this morning about UV unmapping and are doing a talk tomorrow in the main track. I forget the time, I'll tell you by then. So Studio Niskota, we saw this posted online and we knew there were Forest Pack images, and well obviously that's got to have some Forest Pack in it. I mean there's probably some post-production in there, but it's got to have some Forest Pack in it as well. So we got in touch and asked if we could just feature it in our gallery because it looked cool and did you use Forest Pack, and they said yes. And then they told us a lot more about the project, and then finally we agreed to kind of use this project for our promotional purposes, which we're doing now, and for some teaching, which we're doing. We've put an article in 3D World about it, and the guys have been really great really helped us, and it's a really, really nice project. So if you get a chance to hear talk tomorrow, I would certainly encourage it. But for now, I'm going to talk a little bit about how this was actually made with Forest Pack and RailClone, and use that, like I said, as an excuse to talk more about it. So, first of all, here's the full scene. And what was really interesting to me was that these guys have pretty much a no-post philosophy. So they try and do as much as possible straight out of the render engine. Which means, of course, that everything has to be geometry. These mountains weren't positive in the background afterwards, all the trees are real geometry. And from this angle, it's hard to tell just how far back this scene goes. There's a lot of trees there, I promise you. So this is a perfect candidate because no post means all geometry. And all geometry usually means Forest Pack. It also meant, or what also struck me as interesting was the level of detail they went into on the objects that they created. So for example, there was a boatman scene, I imagine most of you spotted it. I believe this was a stock model, but I'm happy to be corrected, but they completely repainted all the textures to make it higher detail. So there's also an axe in the scene. This was modelled and textured from scratch. It's a good job because it plays such a prominent part. You know, where's the axe? This is. Can you see it? There it is. There's the axe. So that's a ridiculously high poly, not high poly, but well modelled, well textured object for something that plays such a small part in the scene. But the benefit of that, of course, is that if they need an axe in another scene, they've got one that will work. They don't need to model another one that's higher resolution. You know, and it's a little bit what IKEA were talking about this morning. It's creating a set of assets that you can use for any purpose, whether you can export it for a game or something like that. So you need to start from the highest possible quality. And the nice thing about the instancing power of Forest Pack is that it enables you to do that because it, to a certain extent, removes the restrictions you have on poly counts and that kind of thing. So you can scatter the high resolution geometry. If you're not exporting it to a game engine, why not use a tree with several million polygons? Just in case it wasn't clear, we're now going to talk about scene setup. So, there are increasingly quite a lot of sexy looking terrain modelling programs on the market. There's Gaia coming out, which looks really nice. I'm sure a lot of you have seen that. There's World Machine for people that have been using that for a lot of years. There are some others. But sometimes with foreground stuff, it's best just to model it with poly modeling, I find, because you get everything just where you want it. You know, you've got perfect refinement, you're not filling out noise maps and that kind of thing. So why not just create a really low poly plane and then just chuck a turbo smooth modifier on top of that, and then you can just tweak that geometry really quickly, really easily, and you can lay it out as fast as you like. It doesn't mean you can't later on like export that as a height map and then refine it, but it gives you a really good basis to start from. So this was me, a video I quickly created to talk about, to play under that description. This is the actual geometry that the guys use. You can see it's pretty similar. But you can tell from the way the polygons are laid out. This is a turbo smooth model. So it's a nice, quick, easy way of creating the foreground geometry. The other thing you'll find when you're using Forest Pack, if you use displaced geometry or geometry from one of those terrain editors, because of the noise, you quite often get a lot of very small peaks and troughs. And if you're creating large areas of grass, which you scatter, as you'll see, in patches, big patches, when they hit one of those peaks troughs, they tip up like that. So you'll end up with a big patch of grass stuck up on one end. And that can be quite distracting. So what you get with this is something that's a little bit smoother. Otherwise you have to make your patches so much smaller and then you're not that optimized. Hey, this is a quick block-out. So when you're creating your compositions, of course, you want to put the major elements in, the most basic geometry that you ever can. You all know this. Another thing, you don't, this is, I'm trying to show off with a long word, discontiguous landscape, basically landscapes that are not connected together is the point here. There is a temptation when terrain modelling, you think this landscape has to be one long, perfect, contiguous surface. It doesn't. As long as it works from the camera, and in all of these renders, the camera is here, we can hide the fact that loads of bits of this are missing and add interest in the background without having to fill in this huge area with trees that you'll never ever see. And on that, just a very quick tip, if you have got some kind of high resolution scene you've exported from either real-world data or you've created it with a terrain editor, one way you can kind of create that effect, it's a very quick cheat, is to just select the object, just go into polygon mode, turn on ignore back facing, and just select everything in the scene. And basically what you've done at that point is you've just selected all the polygons that are facing you. And then it's a simple case to invert that, just Control and I. You've selected all the polygons that are facing away from you. Don't just delete them because it's generally bad practice. I personally don't advocate destructive editing, so if you can keep everything parametric, do so. Add the delete mesh modifier on there. And what I've basically done is removed all the surfaces that are not facing the camera. And from the camera viewport, it looks the same, but I've halved the number of trees that are necessary in order to create that. And why waste time rendering those trees? They weren't visible anyway. There's also some other high poly objects in this scene, some very nicely modelled assets, which is some power lines. I didn't realise quite how high poly these were until the guys sent me the scene, and I looked at them and realised they'd modelled like every single sort of rivet on these things. So these would work perfectly in close-up as well as far distance. But let's play another game of find the asset. Where are they?
Behind the tree.
Yeah, there they are. There they are. So, these were made with RailClone. Well, they were modelled and distributed with RailClone, and RailClone is also capable of instancing geometry. So they can be as high res as you want. We're not too worried. Which is a good excuse to talk about the basics of RailClone. How can you use RailClone to create these power lines? Okay, and this is where we're going to start off looking at some of the basics and some of the principles before we dive a bit deeper. So, first thing you need to understand is how RailClone actually works. What's RailClone doing behind the scenes? Understanding its generators. Once you've got those, really RailClone becomes easy. But if you don't understand those rules, then RailClone can make you scratch your head a little bit. The L1S generator, which is one of two generators, is the easiest to understand. Oh, we did actually want to see that video, thank you very much. So, this is, just fighting my computer, bear with me. This is RailClone, this was the graph editor. What we had at the top was a spline, and these are the two generators that we have. There are only two generators in RailClone, so there are only two types of array you can create, a one-dimensional and a two-dimensional array. You basically create these by just dragging them into the graph editor. Those who have used RailClone will know this. You can see it has a number of inputs on the left, and it's got a place for a spline and a place for a clipping area. So just to blue Peter it, come over here. This basically is all your possible inputs. Sorry. I'll jump ahead. Okay, so these are all your possible inputs here for geometry. And what basically RailClone should do is it creates an array using a spline or just a measurement, and it lets you target different parts of this array with different pieces of geometry. That's essentially what it does. Now there's some advanced deformation and instancing and stuff like that, but basically it's an array, and you can say I want something at the start, at the end, maybe something in the middle, distribute something in between. So these are your 5 options with the L1S array. One at the start, one at the end, one on the corner. The corner is a vertex on the spline. Evenly spaced segments. You can control the distance between them. And then finally, between all of those, default segments are placed. That's basically it. That's simple-ish, right? So we can create a power line with that quite easily. Before I get to that, I'm going to take a little diversion. This means diversion. And just talk a little bit about how the geometry is aligned on that spline, because that's one of the other key things that's helpful to understand, and particularly with this power line, you need to understand it. So this looks not complicated, but this looks a little bit like strange, but it's the way it works. Okay, so when you add any geometry to RailClone, automatically, or by default, it's in automatic pivot mode. That means that RailClone is choosing where to place the pivot on that geometry in terms of aligning it to the background spline. So, along the x-axis, if you put geometry in the start, come back, if you put geometry in the start, it will align it so that it's to the left. You see this? With this segment, the alignment is on the left. If you put it on the right-hand side, or the end, it's aligned to the right-hand side. Default segments are on the left, evenly segments and corner segments are in the middle. But that is the automatic placement. That's how it's working. And then it builds up. So that's on the x-axis. That's if you're looking at top of the spline, that's, you know. On the Y alignment, well, that's really easy. Everything is centered. So this is as though you're looking at it from above. Y alignment, everything is centered. Unless you're doing an A2S array, two-dimensional array, and then it sort of follows this pattern. So I'll just wait for this to reset. So then the bottom is aligned to the bottom of the segment. The top is aligned to the top of the segment. Default is to the bottom. Evenly is in the middle. Builds up like that. And then the final one is the y-axis. Everything is aligned to the bottom of the bounding box of the geometry. Yeah? That's how those work. So it's just something to bear in mind. So here we have two segments that we're going to use to build this power line. We've got the tower itself, obviously, and the cables. Can anyone see what might be a problem if we add this to RailClone and use the automatic pivot placement?
There's that pivot you want with the bounding box of the chords.
Yeah, exactly. The bounding box of these chords is going to mean that the chords end up on the ground. That's going to be the issue. That's why it's worth understanding how this works, because it means that we're going to have to use pivots. So you can see that the pivot is already aligned, so that if I align it to the pylon, then it's in the right place. So I've just made sure that those pivots align before we add these to the RailClone. That's basically it. That's all there is to it. Okay, so how you do it? Create a RailClone object. Open the graph editor. New linear array, and we want to add a spline to that. And pick the spline from the scene. The background here is the spline, and connect it to the spline input. Straightforward. We're going to pick the geometry from the scene, so we're picking the pylon, and add it to the start, so it's at the beginning of the spline. Add it to the end, so it's at the end of the spline. There I'm indicating with the mouse that we want it somewhere in between. There's also display mode. So what I'm playing with there is display mode. So this geometry, as we know, this is very high polygon geometry. And if we were to create like a field of these pylons, very quickly the poly count in the viewports is going to become imaginably high. So we have different ways to preview this in the viewports, even though it's going to render full geometry. So mesh is obviously the high poly way, which we'll probably use for this demo just so you can see it, but also you can just display boxes, which is the bounding box. That's also helpful for working out your alignment. And we've also got a points cloud display mode, which is very fast and lets you still get a sense of the geometry itself, as we'll see. There's also an adaptive mode so that it will trigger points cloud mode if it exceeds a certain poly count. So, adding to the corner, there's no corners on this spline yet, but if there were. And then we want to bring in the cables. Now you're going to see the problem that we just talked about. If we bring these cables in and attach them to the default input, they're on the ground, right? Because they're at the bottom of the bounding box. Okay, so what we do is change this alignment here. So you can see that you've got options for X, Y, and Z alignment to change it to either manually left, pivot, or right, or automatic, or in the case of some of these others, top, bottom, center, automatic. Okay. In this case, we'll change it to pivot. And then we'll do the same for both of them, because we align the pivots to both of them, and that will also pull the concrete base down into the ground a little bit. And there you go, the pivots are now, the power cables are now in the correct place. So, the evenly segments, we've also got a control there for that, which is this distance control here. This basically controls the spacing between these evenly segments. Now, I'm pointing to segments that don't exist yet, but you'll see in a minute. And that's how you control that there. And there are a couple of modes, actually. I don't show you the other mode, but there's distance mode, which we're using at the moment, which uses just a basic spacing in between. There's also a count mode, so you can say, I always want 5 pylons on this, and it will always, no matter how long the spline is, there'll always be 5 pylons. So we'll just plug it into evenly. There you go, that's a lot of pylons. Now we'll just change the distance. And there you go. So there's another problem there as well, which is the cables are being sliced. But before that, I want to mention this, which is that, generally speaking, we're talking about making assets easy to reuse. If you can, come on, Kat. If you can, you want to try and make the important things that you're going to need to edit available from the modify panel, as opposed to having to open the graph editor every time. And so, what you can do is you can take nearly any parameter in here. I'm taking it back too far, but you can take nearly any parameter in here and you can wire it up so that the parameter becomes available over here in the modify panel here, in fact. So at the moment, see, if you're giving this to another artist who didn't necessarily understand RailClone, they'd have to open this up, find the parameter, and edit it. But if you wanted to give it to someone who didn't know RailClone and still have it usable, you can do this, which is to export the parameter, wire it to a numeric node, which is there, and any numeric node automatically shows up in the parameters rolled out here. Give it a name, give it a type of unit, and now you can control that from here without needing to open the graph editor. So that's really useful if you're sharing this, or if you don't want to, if you want to be making quick edits, you don't have to be opening the graph editor every 5 minutes. The other issue there is, as we can see, that the cable is being sliced there. And that's because the cables just tiled until they hit another segment, evenly segment, and then they just get cut. That's the default mode. What we have instead up here is several modes of default segments. And the one we're after is called scale, which basically puts one default segment between evenly or corner segments. So now we have one pylon cable between the pylons themselves, between the towers themselves. Another problem. You can see there's a gap. And that's because if you switch to bounding box mode, it's actually stretching it between the bounding boxes of this geometry. So it's hitting the bounding box and then getting stopped. So what we need to do there is to use a properties of the segment node, which is called padding. So we'll do it to the cable itself, and here's your padding option here. And what padding does basically is lets you either add extra space to the ends of those segments, so add a gap, or subtract a space to pull them in close together and overlap segments. So if you use a negative, it overlaps it. There you go. Getting the right parameter. I'd probably do this in points cloud mode normally because it's a bit faster. And there you go, there's your completed pilot. Points cloud mode is fast. We can quickly and easily edit the spline. And you can of course change the spacing if you want to as well. Are there at this point, because that's sort of the fundamentals of RailClone, any questions from people who have or haven't used RailClone before about that? About the way it works?
How can we save this for use in the different sense?
It's just a max object, so just
like RailClone.
yeah, the RailClone, but it's
Like
like a preset.
oh, it is a preset. Okay, that's a bigger question than I will answer. And remind me at the end because I can show you that really easily. But basically, you do save it in a separate max file and then you add it to the library. That's a short answer. So you save it on its own in a max file, and then you add it to the library as an object, and then you'll be able to just put it in.
Can you make a tutorial from the website?
There is one. Well, there's one for Forest Pack actually, but it's the same process. But I will make one. I will make one. Okay. So obviously that works great as long as that spline was flat on the ground like it was there, but we're applying this to an undulating terrain. So we need to learn a little bit about surfaces and deform modes and how those work so that we can get this looking as we want it. So here is our current pylon, but here is our surface. It's lumpy. If I apply the pylon to that, fine, but it's floating. So I need to get it down onto this ground. So this is really easy actually. You just apply surface node, you pick the surface from the script scene, and you just connect it to the surface input of the generator, and it projects it down onto the ground. One problem, these pylons look dangerous. So bear with me. So we have various options up here for changing the way that those deform vertically. And there are a couple of other options here too which can help to optimize your scene. So in particular, one thing I see people not doing when they get sent things is turning off bend and slice when you don't want your geometry to be bent or sliced. So these pylons, for example, if they're going round a corner, bear in mind each one of these is a million polys probably, you don't want them bending to follow the curve of the spline underneath, because they don't do that in real life, and all you've done is you've taken the instancing away from that object the moment it's bent. Anything bent is not instanced. Similarly, at the ends of the splines, you don't really want them to be sliced either. That shouldn't happen with the way we've set this up, but just in case, you don't want those pylons to be sliced. Anything that's sliced isn't any longer instanced, so you've hurt your optimization again. So you want to turn those two off. We also have some modes here which govern the way in which this geometry is deformed vertically. Now, because I've turned bend off, the vertical one is disabled. We'll look at these in a little bit. But what I want to do is to make sure they stay upright. So you'll see there's a mode at the bottom there which is fairly self-explanatorily called stepped mode. And that will do what we're looking for. So if I turn stepped, my pylons are upright. That's it. They're no longer deformed, they're always upright, they're just stepped. These cables, they need to be in something called vertical mode. Now this doesn't look like it's working according to the points count, it's just a points counting. But vertical mode is a kind of version of step mode where it kind of warps it that way, I'd say. So it keeps the verticals vertical and it just kind of warps it like this to make sure they match. And if you render it, you can see just about, maybe not on this screen, but the cables are joining up correctly by using stepped mode for the pylons and vertical mode for the cables. Okay, so a little bit more about surfaces and the way these work. As I mentioned, there are these several modes. So this is, you can see I'm having a real fight with my computer, so I apologise for this, I will get used to it. Okay, so this is the mode, the automatic mode. It's called adaptive mode, and basically what it means is that your geometry is coming out perpendicular to the spline. Okay, you've got a spline going on here, everything's coming out. If it was curved, it would also follow that shape. We've also got step mode, which you just saw, but there is a more advanced version of step mode which does this. So what's happened there is I've got stepped mode, but I've made the bottom of it vertical. So the top part is stepped, it's remaining horizontal, but the bottom part is following the spline. So it's a hybrid mode. You can do the same thing to the top as well. So you can have the bottom flat and you can have the top follow the spline. There's also vertical mode, and this is the mode, like I say, which gives you the kind of warp like this. It basically keeps your verticals vertical, but keeps your horizontals following the spline. This has the two options as well, so you can have a vertical mode, in which case the middle is still going vertically, and you can flatten the top and the bottom. If you start stacking these up, so you've got your railing coming in here as well, also with vertical mode keeping upright, you can start to create some really interesting little quick procedural objects that would be very difficult to model in another way. So here quickly I've created a railing to go around a stairwell. And you can even do the stairs if I change the stair object to stepped. Then I've got the stairwell there too. Wasn't obvious from the last one, but with two-dimensional arrays you can also deform objects by projecting them down onto geometry. So this is a 2D array, it's multiple objects, projected down onto geometry. It all updates in real time, it's fully procedural. And all I would have done for that is just attach the surface node to the A2S generator. You can see I can change the surface, I can change the spline, whatever. It's great for things like light poles, where you can project them straight down, everything's fully parametric. So I can change the spline, everything moves. you can also mix the deform modes with this projection, as we just saw. So in this case, this fence has sticks, but it has vertical fence panels, I should say. So it's a mixture of those two things. That's more or less the same approach as we used on the pylons. And then this one, there's a mode here which is a little used, a line Y with surface. And what that basically does with your linear array or one-dimensional array is it will take your segment and it will deform it to follow the surface on the Y-axis as well as on the X. So we didn't use that, for example, on the pylon because we don't want the pylon tilting over. But in this case, because this racing track is going around this camber at the end here, we do want them to bend over to follow that. And all you do is turn that on. And it works. And likewise, that's parametric. Okay. So you can change this anyway. I'm not sure about those light trunks posts, but you get the idea. So that's very quickly the surface and deform modes. So the other RailClone object picked on in this scene are the boardwalks themselves. As an excuse to talk a little bit about how you can create things using multiple generators, but also some of the tricks for randomizing stuff, and also exporting parameters and a few other things. What I said is often it's easier to combine generators, and we in the support team as well, we see this all the time, and I'm as guilty of this as anyone else. When you've got a generator and you've got all these nice inputs, the temptation is to try and do as much as possible with as few as possible generators as you can. So I will always try and get everything into one generator. Why? It's a silly idea. If it is better to use 3 or 4 generators together, then do that. There's no prizes for using as few as possible generators. So my advice would always be like, do you need to do that in the same generator? If not, add another one. It's quite easy to do it that way. So this is a good example. Here we've got some pretty basic geometry. Pretty basic segments. We've got 3 planks here, which are differently textured, but also have some kind of wear and tear on them. And for this purpose, I've got 1 post, just to illustrate a principle. You could use multiples. I can't remember if you had multiples in the scene, but here we have 1. So what we're going to do is we're going to use 1 generator for the planks, 1 generator for the posts, and we're going to look at how to randomize those a little bit so that the repetition of those assets is less obvious. There's also this kind of arrow which I'm going to use to illustrate something in a second. So we have spline for the boardwalks. So basically we create a RailClone object. Same setup, open the style editor, and then you open a linear array. You need a spline plugged into that, and you just want to pick these planks from the scene. I'm just copying and pasting to add the others. You could use add multiple as well, there's a shortcut for that, but I've got those 3 there. So what I'm going to do there, I've added a randomized node. It does what you'd imagine. It randomizes the things you connect to it, so it's pretty straightforward. So in this case, we're going to add 3 planks. It's going to randomly pick from those 3 planks. That's all it's going to do. It's a little bit more powerful than that because actually each one of those planks does have a probability setting, not shown. But you could say actually I want 20% plank 1, 30% plank 2, and whatever plank 3, and it will. You don't have to add those up exactly to 100. It works that out for you. So we just connect those to randomize. So there we have our planks. So those of you who are familiar with Forest Pack, and those of you who are frustrated by RailClone sometimes, will know that RailClone doesn't pick the material off of your source geometry. Yeah, so you see it picked, because there's no material on it. Forest Pack, of course, you'll know, does pick the material off the source geometry and consolidates it into one big multi-material. RailClone doesn't do that. So it means that you have to create materials that work with your RailClone object, which means that if you've got multiple sources, the material IDs on those objects have to work as though there were one multi-sub-object material applied, if that makes sense. So in this case, I'm just applying the material manually now. I've just picked it off the planks and I'm applying it to the boardwalk. Pick it off the planks, stick it on the boardwalk. So we want to add a little bit of transform randomization to these. Now there are 3 segments there, so ideally we don't want to go into each one of those segments and make changes. Ideally, we want to do that in a mass way. And that's where your transform node comes in. So if we pop a transform node in here, what this lets you do is to add kind of transform randomization. I should employ someone to do this, I think. Here we go. Let's go from there. So yeah, this transform node will basically apply randomization or transform randomization. Basically, you can change the padding, you can change the pivots, you can change the fixed rotation scale and transforms, and randomized rotation scale and transforms for anything that's plugged into that. So what you don't want to do is go and have to do it to each one of these 3 things individually, because that's slow and tedious, and it makes it really hard to update. So we've got this instead. So these boards all look too similar still. So first of all, let's add a bit of space between them with our padding. 2 centimeters is enough. And we come to transform up here, and we can start to add some randomization. So we can randomize the translation, we can randomize the rotation, and we can randomize the scale of all of those things. And it's affecting all 3 of the segments that go into it. It's really nice and easy. You can see I went a bit over the top there, a bit too randomized, and just reel it back in. There's also there, let me just point that out, something a bit weird going on. This work? No. So there's a kind of weird little slice here. I don't know if you probably can't see it from the back. There's a little bit of triangular sort of plank here. And you might wonder why that's being caused. Well, it's because on the spline here, there's a vertex on the spline where we've drawn the curve. And at that vertex, what's happening is RailClone's seen it and it's decided to slice that plank so that it bevels around the corner. That's all that's happening there. But it's created this kind of triangular bit of boardwalk, which maybe we don't want. So what we can do instead is just turn off bevel mode, basically. So you've got bevel mode up here, you just put that onto none. Bevel mode. If we just put that to none, then basically when it gets to a vertex, it's just going to deform the geometry instead of bend the geometry around that corner instead of slicing it. There you go. But now we've got one weird shaped one. So that's caused because of the interpolation of the spline. The spline's, it's got this quite low interpolation, so it's quite sort of jagged as opposed to being completely smooth. The solution, therefore, is to increase the interpolation of that spline. And you could do that by going back to the spline itself and increasing the optimized spline settings. Or what you can do is you can override all of the splines in RailClone. This is one of those other handy little settings. If you're not familiar with it, it's really useful. This curve step setting here will automatically optimize any splines or increase the number of curve steps for any splines that are currently attached to this RailClone object. Basically having the effect of smoothing out the deformation. So if you find that the deformation is very rough and jagged, then increase your curve steps, it will probably fix it. And the other thing is that curve steps on the spline objects are limited to, I think, 100. In RailClone there's no limit, so you can go beyond the 100 curves. So that smooths that out. Okay. So now we want to add these posts as well. And to do that, we're going to add another generator. Of course, you want it driven by the same spline, so you add the same spline to it, and we want to bring in a segment. Now, I'm not going to bring in the post quite yet. I'm going to bring in this kind of weird arrow, because I want to illustrate how you can randomize a single object by mirroring it. So here we have one arrow, which is clearly duplicated. What we're going to do is create some other variations of that. Just fiddle around with the evenly spacing bit first. Then turn off the slice. Right. So, what we've been looking at so far are the built-in nodes. What I've just switched to is a second panel, which is called macros. Macros are a relatively new feature in RailClone. Who has used macros? A couple of people. Okay. So what a macro is basically it's a collection of nodes packaged together into a single new node with its own inputs and outputs. And it's a really nice way of simplifying your graphs and being able to create easy-to-use single-node new features, basically. And what this means is that although RailClone looks like it's only got these few nodes, actually if you switch to the macros node, you've got all these effectively new features that you can play with. And in this case, what we can use is one which is called mirror variations, which is included. You can create these yourself as well, by the way, and there's more on that later. But which is included with it, which basically just randomizes the mirroring on the X and the Y and the Z axis. So you can see all of the macros here. There's the one we want. Just connect that up in between the existing arrow and the generator. And now I've got its own parameters on the left-hand side over here, X, Y, Z, pretty straightforward. You just turn those on and it's just mirroring on one axis, the other axis, and the other axis, and it's just shuffling that randomly. It's a really nice way of getting loads of variation out of just a few objects, if they happen to be different on each side, of course. If they're the same on each side, no point. Okay, so let's assume that we've swapped that for our poles. There they are. Now, of course, we want to put that, instead of being in the middle of the slide, remember, centered in the middle, we need to put it over to one side, of course. So the generators have offset parameters. So here is your offset parameter here, Y offset. So I'm doing the wrong generator, even in the video. I can just change the offset of the post and pull this over to one side, just moving it over to one side. Pretty straightforward. What I need to do then is to create the other side. And of course, you could say, okay, let's create another generator and change the offset, but actually, the linear generator has a mirror option, which will automatically offset it the same distance to the other side of the spline. So there you go, you create both sides with one click. So that's one of those times when creating another generator isn't the most sensible solution. In that case, it's easier just to do that. We can, of course, then apply a surface, which we've learnt about already, just to drive this down to the ground. There we go, that's down the ground. Now we're seeing the same problems we had with the pilot. Uh-oh, wonky posts. So we want to set that to stepped. And we're getting there. So we want to bring this up off the ground, obviously, as well, so that it's not sunk into the soil. There's a little bit of a step there. Okay. Once again, we've got a style here that's nearly finished, but we want to make it easy to edit. This little dialog box here is actually worth mentioning, because if you're an old RailClone user, you will be aware that this didn't exist. This is a relatively new thing that lets you export multiple parameters at once. So it's a small thing, but it's a big time saver. It used to be you had to right-click export parameter A, right-click export parameter B, right-click this, pull up. So this just lets you export multiple parameters. As it is only one. So I'm just connecting Z offset to this, scene units. Now I can control this from over here. Consider that good practice. Always try and make as much as possible editable from the modify panel. This one, I want to control the distance between the posts. So this time I export the evenly distance. Then attach a numeric node. And it will come up over here. That's too many posts. So we can control that too. Nice and easy. So we can, as you can see, control that. Now, let me just stop that for a second. There is an issue, not an issue, but it's the way that this offset mode works. If you look at these posts from above, you'll see that they're not opposite one another, right? They're diagonal. That's an interesting straight line. They're diagonal, like that. Why is that? Well, it's because, in effect, when you use the mirror and offset modes in RailClone, sort of what you're really doing is you're creating a separate new spline for each one of those sides, and you're offsetting it from the array. The result of that is that each spline is a different length because of the curves. Not if it's a straight spline, but because of the curves, it's a different length. Which means that the evenly distances are calculated separately on each side, and they don't line up, as you can see. Now in this case we did want them to line up because there's a crisscrossing of lines. that goes across from one to the next. So it's just not the way the style this should look. Fortunately, there's a simple solution, which is going on these little buttons that not everyone's necessarily aware of. But if we come into the generator and just go to the rules, go down to your evenly settings, support it there, and then you can see there's a little tick box there called sync offset. And what sync offset does is basically means that these two posts will always remain opposite one another on the spline. It compensates for the difference in spline length. So there you can see that's changed. Now I put it back in. Turn it on again. You can see now they're opposite one another. So if you're trying to achieve that, that is the button you need. Good. Okay. So that's the kind of end of the RailClone section for this project. Are there any questions so far? Yeah.
The last example you saw with the offset of the mirror and the project,
yeah.
We had a post that was in the intersection of the planks. How we managed to remove that?
Where, oh, in the planks?
Yes,
right,
intersection,
yeah.
yes.
I didn't spot that. In that case, I would use I would change where that intersection is. Yeah, because there's a bit of joint, isn't
Yes.
it? Where that intersection is, I would put 2 extra vertices on either side of that. I'd change the material ID on that section of spline and create a conditional rule that says don't put a post here. Yeah. So we're going to move on to Forest Pack and look at adding the trees. So just very quickly, how many models are required to disguise repetitions? Question we get on the support forum a lot. How many tree variations do you need to create a good forest? Is it 2? Is it 20? I can't answer that. Sorry. But basically what I would say is that if you are going to add tree variations, make them sufficiently different from one another. Often if you're modelling something in GrowFX, you've got this nice rule-based system, and you might, click the C button to create a new tree that's got some branches, and it'll go, yeah, thank you very much. I'm going to move my branch from here to here, or here to here. And then, when you randomise it anyway, you're not going to see that difference. So the nice thing about these trees is they're all quite significantly different. And just as an example, with a bit of transform randomisation, this is what you can do with one tree. So here's one tree. There's some texture variation on here, so they look a bit different anyway. But if we just go in and we just change a few things by randomising OK for that translation, which just moves them off of any grid that they might be on, we can change the rotation a little bit. Maybe it's a windy place, let's bend them over a little bit more. We can crucially change the scale and maybe increase that a little bit, like that. Now we've taken our one tree. OK, it's still the same tree, but it's significantly harder to spot the repetition than it was before. And that's one tree. So by the time you've added 3 or 4, like you saw before, you're starting to make it very difficult to spot the obvious tree repetition. Second question we always get is, what's the most efficient way to import objects? Well, okay, I'm going to take a small diversion here and talk about the Forest Pack 6 feature. In Forest Pack 6, we have added an update manager to help you download new assets from us. Those of you who've used RailClone will have seen this already, because it's already in RailClone. Basically, this is what it looks like. It's a little manager that pops up, and it shows you any updates or any new libraries that are available. Why have we done this? We've done it because we got to a point with the single installer that the file size was too big to include more objects, so we needed to separate these two things. So basically, you log in with the same login credentials as you used to get into your user account, and then it will show you what's available to you. If you want to install something, you just make sure it's selected, and then you hit install. You can also see what you've already got installed by choosing installed packages. So that'll show you what you have already. And then, yeah, so you just click those and you hit install, and it runs. I might have sped up a bit. There's also an option for offline installation if you need it. So if you're trying to render to computers that aren't online, you have that ability. And once you've downloaded them, they're all just automatically added to your library browser. There's no further steps. So you can see that these new libraries are all just here. So the reason we did that was because we had a number of new libraries that we wanted to include. One of which being a new tree library, which is about 10 trees in sort of 2 variations each. So I think it's about 20. I can't remember off the top of my head exactly how many. But we got to this point where a lot of people were downloading Forest Pack and then they thought, oh, now I need to buy some trees. So we've included some to get you started. Okay? These are high quality trees. They were made by a well-known vendor, who I won't mention. And they are several gigabytes in size, which is why Update Manager is necessary for you to be able to download them without having to download it every time you want to update the plugin. Also means we can do other things like release new macros whenever we want, release new forest effects, which we'll see later, whenever we want. So back to the question, which is how to import geometry Forest Pack. The question we get asked quite often is, what's the best way to do it? Should I have the trees as objects in my scene? Should I import them as V-Ray proxies? Or should I XREF them into the scene? And again, this is a difficult question for me to say definitively this is the way, because each one has benefits and disadvantages, advantages and disadvantages. Mesh obviously has the disadvantage of increasing your scene size if you save them there, so that's probably the biggest drawback to that. But it does have some advantages in that you can sample animations on the fly, so your animations can be done procedurally on that object, and for each frame it can sample that frame in the moment. Now if you do that with a V-Ray proxy, you have to bake those animations out. The best example is to think about something like procedural geometry objects like grow effects, for example. So if you have a grow effect and you apply wind animation to that, those animations are sampled from a procedural object. You're not having to bake them out. You're just snatching it at that given moment. Now with a grow effects object, of course, that is also a very small object in terms of memory size. So you can save that in your scene. You don't have to export it to a proxy. In fact, I wouldn't with grow effects. And you can change the animation at any point. You don't need to update your proxy. Forest Pack will just resample it from your changed grow effects object without any need to do anything else. Same if you're just applying simple noise modifiers to things to create effects and things like that. You can just snatch it from the object without needing to bake it in. But like I say, the disadvantage is it's loaded into memory, and it's loaded into memory at render time too. So which is where the proxies have the edge, right? Because proxies are only loaded in when you need them. They're loaded dynamically, and crucially in V-Ray, they're loaded when a bucket hits them. So if a bucket hits somewhere a proxy sat, then at that point it loads it in. That's a big memory saver. Of course, your scene file sizes are reduced, so you don't have these slow saves and loads. But animations are pre-computed, so you have to bake your animations out, and if you make a change to your animation, you have to put it back, put it back into the proxy. But also they're faster. So like a grow effects model, for example, takes a little while to calculate each frame, which has to render, which has to compute for each frame. Whereas if you pre-computed it, it's faster. And then there's only partial support for tint by element. We used to say there was no support for tint by element with proxies. That didn't work. So those of you who don't know, Forest Colour has this ability to tint individual leaves randomly with different either materials or maps, or from gradient or whatever. With a proxy, the only way to get that to work is to make sure that proxy is set to full mesh mode in the viewports. So it has to display the full mesh, and then tint by element works with proxies. But of course, then you've loaded the full mesh. So there's your disadvantage. Direct XREFs are very similar. They're loaded into memory though, the same as the mesh. They reduce your scene, they reduce your scene file size, so your saves are still fast. You can sample animations on the fly if you go back and change the XREF. And they do support tint by element because they've imported the whole mesh. There's not much in it, really, but I would always veer towards XREFs or proxies. But what there certainly isn't is a need to convert geometry to a proxy in order for it to be instanced. And that's a misconception for some people. It's as efficient, really, apart from these minor drawbacks, it's as efficient if you just click on a mesh in your scene and then use Forest to scatter it, because behind the scenes what it's doing is converting it to sort of instance geometry anyway. Yeah? So you don't need to create a proxy. You don't have to do that. You can use any of these others. But there are just a few caveats. Okay. So you think something like creating a Forest Pack object was simple? There are a few options actually. First is you can create stuff just by clicking straight off the bat by choosing custom edit mode from the create panel. You can just do that and then you can change the tree later. So you can just go and go, oh, do you know what, I want a tree there, I don't care what it is at the moment, and then I'll change it later. There you go, I've picked a tree. So that's the first way that maybe people aren't using it. Second way, generate mode, yes, but did you know you can also pick something from the library before you apply it to a spline? So I can pick a type of bush, for example, that I want to use, or a few bushes. I can choose whether to merge them or XREF them to the library, to the scene, sorry. So you can do that from there. And then you've got them added, all you need to do is apply it to the spline. So this can be really quick if you're quickly populating a few splines and you've got presets set up. So you plug in. So what you can do is you can just draw an icon, big Forest Pack icon now, and then you can go back in later and add the trees and everything else whenever you want. Now it also makes certain sense when you realise that you added some new distribution modes which don't rely on you picking something from the scene first. So we've got some new reference modes which you can use to help pick reference markers. I'll show you them later. And we've got a spline mode which lets you distribute along splines like RailClone but in Forest Pack. And this time procedural. So it was always sort of there in Tree Editor, but now you can change the spline at any point, you can change the spacing between objects and all that stuff, and it all updates automatically, as I'll show you later. And we've also got the ability now to scatter on particle flow events. So that's brand new. So once you've created your Forest Pack object, the next thing you're faced with, right, is the interface, which, okay, we admit, is big. It goes on. We acknowledge that if we saw how long Forest Pack's been around, it's been around for a long time. So we want to make this easier for you guys so that you can have a simplified Forest Pack experience if that's what you want, where you can unlock the full power of it if you want to too. So what the changes we've made basically are we've added a new option here which lets you disable the roll-ups you don't need. So you can create a simplified experience. Get rid of the display and never use it, or about. I'm not doing animations, so I'll turn that off, and we use the shadows anymore. So I've made that much, much simpler now. You can also disable your pop-ups, so if you get irritated by these sort of pop-ups every 5 minutes, turn them off. You can do that from there too. Now we've got a much simpler Forest Pack interface. And the other thing we can do is we can fold down different bits of the interface that we're not using, like, okay, I need that rollout, but I don't need diversity or collisions, I'll turn those off. And that sort of persists between sessions, so you don't need to do that every time. But if you need it, you just open it. So hopefully this will make Forest Pack a little bit more user-friendly for you guys who are doing day-to-day work and maybe don't need all the rollouts for every job. Just unveil them when you need them. And I'll leave it. That's all right.